Hi there, this is Pranav from DPS Diary. Good morning, afternoon, evening, depending on your geographic location. I hope you are doing great. So today we are going to cover isolation, blocking, and then latch also, like how do we really see the latch, and also like how do we see the content of page. So when you get blocking, you will get the page number, right? So what is the page number on which it is blocked? So we'll see all that. So this is in the Sybase training session that I have scheduled. So it is one of those sessions, right? So let us start. And if you like my content, please do like and comment for your in terms of your feedback, and do subscribe to my channel so that I will keep recording the sessions and I can share with you, and it could help the Sybase community as a DPA community, right? And I've also heard that this is also helping the developers, Sybase developers. So from their perspective, if you want me to cover something like triggers or anything that comes to your, which could help you, do let me know. Okay. So let us start. Let me start the recording first. Okay. So let us start from the scratch. So let us do show server. So it will show you which all servers are running on my lab. So you can see there is AAC1 server here, and then you have AC1.log. So you can see from here. So let us log into this server, AAC1 minus USA minus W. Windows for the Windows size. All right. Okay. So let us see which database you are in right now. So db underscore name, if you run, you will get the database name where you are currently located. I mean, that's how we should use the term, but in which database you are right now connected, right? So you should check this, because at many times I have seen when sysadmins or DB admins create your login, then they put default database as tempdb or maybe some user database, right? So here we are going to create some database, one database with the device and other thing, and then we'll continue with our session, right? So this is disk initialization for the user db underscore data. Let us paste it here. So this data will be for 100 MB, right? And now we'll create the log, that will be 10 MB, and this is where we'll create our database. So database will be 100 MB data and 10 MB log, right? So this is done. Now let us use the create database statement. Create database user db underscore user db on user db underscore data and user db underscore log. So you have to specify both and how much has to be allocated. So it's not hard and fast that you should allocate all the size that you have initialized, but it's a good practice to include them all. Okay, so now database will be created here and it will come online. So now you can see database is online, right? Now let us for our lab purpose, let's create one table. Okay, and then so here I am following the best practice. So I have specified ID column, which is int type, and identity column, and also primary key clustered, right? So I have to cover like clustered and non-clustered, and how it actually varies depending on the index ID, and how the physical order of data or physical sorting happens on the disk based on clustered and non-clustered. So you can have a primary key which could be clustered or it could be non-clustered, right? So let us see, table is created. Now let us do some insertion of row. Okay, so let us do insert 50 rows. Okay, and you can put go and 50. So this will insert 50 rows into this test table. If you would have noticed, I am not using ID column because it is auto incremental and it's identity column, right? So now if you check select count star from test, you will see it is having 50 rows. Also you can run the command sp underscore space used, and this will also give you a number of rows, sp underscore space used and test. Okay, so you can see there will be 50 rows here, and it will also give you size of thing. You can also run the command sp underscore space used test comma 1. So this will give you size of each and every index. Okay, so here you can see test id This is your primary key and this is your table, right? This is basically clustered index and primary key. Okay, so now let us talk about blocking. So deadlock we have already seen in one of the session. I have covered that how deadlock happens and how the cyclic dependency is there. Let us talk about blocking, and then how do we really use the isolation to get rid of blocking, or how do we introduce blocking by using isolation. Okay, and then we'll also see the types of lock. So when we do update statement, so what kind of locks are held at the engine level, or at the table level, or at the page level, or at the row level. So all that thing we can really see in this session, right? So let us start with begin tran. Okay, update, or let us do one thing. Let us see the locking first. What all things we have right now? Okay, so let us use which database right now we are in. Select db underscore name. We should be in master. Yeah, sp underscore lock. Let us see what all things we have. So there is nothing right now. There is no lock which is held right now. This 31 that you are seeing, it is basically your current session, right? 31 is your current session. So there is no lock held at this point of time. So even though we have started the transaction, but then it is not really doing any holding of lock. Now let us do update test. Set name is equal to Kumar, where id is equal to 20. So one row will be affected, and then transaction is open. So this is again explaining about transaction. So transaction is a like a smallest quantity of work that is done at database level. Okay, it can have two like conclusion. Either it could be committed or it could be rolled back. There is one more which is called save point. Okay, but ideally, or normally, I should not say ideally, but normally this is either committed or it is rolled back. So the transaction should be open for the minimum possible time. It should not be left open, because if you leave it open for longer, then it will generate more chance of locking, blocking, and also deadlock, right? So now we have done the update. Now let us go back and see what is the lock which is held right now. So now you can see that this 33, which is exclusive intent and shared intent, that is what is the locking right now. Okay, so and let us see what was our SPID here. So if you go here and SPID, so you will see your SPID is 33. So let us see what all things you have on 33. So 33 is exclusive intent. Okay, that is what is holding right now, and other one is exclusive page, right? 31 was the SPID of this session, so this is here shared intent. So 33 SPID is having two locks right now. One is exclusive intent and one is exclusive page. Okay, now what we'll do, we'll open one more session here and let us log into ASE1. Let us see whether we have the same environment here. So yes, ASE1. So let us log in I square minus S ASE1 minus USA minus W, and let us use database name here itself. Okay, so once you do that, then you are already in the userdb database. You can see from here, right? Now use userdb, you are already there. So select star from test where id is equal to 21. We did update for 20, not for 21. Okay, test not found, it was test table only, right? Am I making some mistake here? Let us do sp underscore help and let us find this. So it is not appearing here. Something seems off here. Select star from sys objects where type is equal to u. So this will give you the all the table in, sorry, select star from sys objects where type is equal to u. There is nothing here. Let's exit and log in one more time. Maybe okay, so let us do echo dollar sybase opt sybase. This is fine, and we did show server, so it was using ASU1. Yes, minus ASU1 minus USA minus W. Actually, if it was not there, it should have thrown error here itself. Okay, sp underscore help db. So yes, it does exist. So and select db underscore name. Okay, so now sp underscore help. For some reason it's not showing this table here. How come? Test does very much exist, but I don't know what is wrong there. So here we are, let me see if this works here. db underscore name master. So let's change this to user db and let us see if this shows here. Is it not? Is it part of the transaction? Let me see. It should not be. Create table, create database. Okay, it's my mistake. Actually, what I have done is I did not use database name here. If you see, insert into test, I have not used this database, right? So basically it is in the master database. It's not there in the user DB. Okay, so if you see here in the sp underscore help, so you will see it is there in the master database. So let me show you here. We're in a master database, right? So sp underscore help, it should have been on top only. Rollback sp help. And test. So it's here. Okay, no issues. What we could do, let us drop this table. Okay, and let us create that in the user database. Okay, so good that we saw. So when you do any lab, you should be in the user database. Okay, let's create it one more time now. So let's go ahead, create this table. Okay, so table is created. Now insert some value into this. So let us do this insert. Go 50. So now you have 50 transactions, 50 rows actually. Select count star from test. You will see 50 rows, and you can also do sp underscore space used test comma 1. So this will show you all that. Okay, fair enough. Now let us do begin tran and update test set name is equal to Kumar, where id is equal to 20. Okay, now let us go and check the logs here. So sp underscore log. Okay, So you can see that 31 is this SP ID, 33 is having two locking, exclusive intent and exclusive page. Okay, now let us go back. So now use this user DB. Let me see, where are we right now? Select DB underscore name. Okay, we are in this database. So now select star from test where ID is equal to 21, and this will be blocked, right? Because you are updating the table for ID number 20, since it doesn't have the data row locking, because by default it will be all page locking, so it is blocked right now. Now if you go back and check the locking scheme or lock of the lock on the table and row, so it is actually, it has changed from exclusive page to exclusive page blocking. So this is blocking now, this is blocking 35. You can see that in the sp underscore who or sys processes. Here it is blocking now on the page number 889. So this is the page which is getting blocked. Now how to solve this blocking? This we have already discussed. So it is all page locking. So if you change this to data row, then this blocking will be sorted out, right? So now let us roll it back. The moment you will roll back, you will be able to see the data here. Okay, now before that, let me show you the locking scheme of this table. So you will see it is all pages, right? Let us change the locking scheme of this table from all page to data row, right? So for that we need to change the DB option first. So let us go into master sp underscore DB option, user DB. Okay, select into and true. Okay, so this is on right now. Now go to this user database and do the checkpoint and change the locking scheme of this table. Alter table test lock data rows. Okay, you can check this by using lock scheme command. Okay, so it is changed to data row. Now let us run the same query that we ran before, and then this will not cause any blocking because it is data row now. So the locking the log that is it will be holding now, it will not be page, it will be row level. So begin run, go update test set name is equal to Kumar where ID is equal to 20. Okay, let us go and see the locking held right now, what all things we have. So before it was page level, right? Page block, and before here also you will see page. Now let us see what happens. So if you do enter, you will see it is changed to row. Okay, that's the difference. And this is already run. So now let us do select the star from test where ID is equal to 21, and this time it will work because we are holding the row level locking and the update is happening on ID number 20, whereas select is happening on ID number 21. So these two are two different rows, and that is the reason there is no concern in the fetching of record. What if I run the select star from ID where ID is equal to 20? Will it work? No, it won't work. It will be blocked. What if we use isolation 0? It will work. But let us see the record here. Name is changed to Kumar instead of Pranav, right? Before it was Pranav, because I have done the update or insert. It is same, like value is same. It remains consistent. It's uniform. I have not changed anything for any row. However, if you see here, it is changed to Kumar now. Whereas I have not done the commit here. It is still open transaction. So if you issue isolation 0, that means you will be getting the dirty record, right? So which has not been committed or it has not been rolled back. So even though it is part of open transaction, it will still show you the record which is in the transaction. It is still in the fly. It is neither rolled back nor committed. Okay, so that record is not a reliable record, right? And you can't use that in the OLTP environment, right? So that is about isolation, how you can use isolation to get the record even when the transaction is open, even when there is a transaction which is neither committed nor it has been rolled back, right? Now let us roll it back. When you roll back and then issue the statement again, select star from test where id is equal to 20. So now it will be different, right? So that is the difference in the legitimate record and dirty row that we have seen earlier, right? Now let us see something else. So I showed you that when we were having the lock, it was putting the lock on the page, right? 873 was here, before it was 889. Okay, so how you can see the content of page, right? So let us see that as well. Okay, dbcc page, the database name is userdb. Okay, and page is 873, 1, 1. Let us see what we have. So you can see all the physical arrangement of data here, right? So you can see what all row, these all things are table level offset, and then you have these all arrays 0, 16, 32. But then you can see like each row, how does it really contain on this page, right? So 43, 42 row number. So we were doing operation on the ID number 20 and 21. So 20 is here and 21 is here. Let us see something else which is important, that will come in the beginning. So this is the beginning of that show page, I mean the DBCC page. So this is there in the cache, this is found in the cache, default data cache, cachelet 1. We have only one cachelet, we have not done the partitioning of cache. Okay, but you should do partitioning of cache to handle Spinlock. Yeah, let me talk about the Spinlock also. So we have latch, let me show you here, latch, this is the latch, this is your latch address. So latch is nothing but a physical address of a page, right? So that is the lowest level of locking, and then this is held for very short duration of time. However, if the latch lock continues, then you do not have any choice but to reboot your ASC. There is no other option which you can really do to get rid of latch lock, and if it is not really getting it's not really releasing the lock. But in 99.9% case, latch will be held for very short duration, and then it will come out of that very soon, very fast. So this is latch. Then you have lock we have already showed you how the locks are held. So you have different types of locks. So shared lock is one which is not harmful, right? Then you have update lock, delete lock, and then lock escalates. Okay, so you have row level, then you have page level, then you have table level, and exclusive lock, and then intent exclusive. All that comes part of locking. So lock creates blocking. So when blocking means if some process is trying to update to write something, it could be insert, update, or delete record, and then somebody is trying to read it, that's when it will get blocked to maintain the consistency of data, to maintain the integrity of data, right? That is blocking. Deadlock is cyclic blocking. Okay, A wants B, B wants A, but then both of them are holding something for each other. That's when the deadlock happens. Deadlock is cleared by the optimizer. There will be one timer. After that, optimizer wakes up and sees which one is easy for rollback, and then that is killing one of the SPID, right? That's deadlock. Then about the spin lock. So spin lock is at the cache level or at the memory level, okay, or at the CPU level also you can say, because that is also affected. So that can be handled, or spin lock contention can be handled by adding more cachelet, by doing more partitioning to your cache. That is one solution that you should do. Okay, so we covered latch, we covered lock, we covered block, we covered deadlock, and we covered spin lock. And isolation, I am already showing you how the isolation actually works. It helps, and then it does lock the row or lock the complete table. So this is the physical address of latch. So let us move forward now. Okay, So let us see what is the next thing. Okay, I wanted to show you the when you do the begin tran and you have not done the rollback. So now if you do select at tran count, you will see it is not having any transaction count right now because there is nothing, no transaction is open right now, right? Now let us see the next one. So we did see when we update and then when we are selecting there is blocking. What if we do select and then we try to update it, right? Even though the locking scheme is data row. So set transaction isolation 3, set transaction isolation level 3. Let me something is I'm missing here. Let me see. Set transaction isolation level 3. Yeah. Oh, set. Okay, my spelling is wrong here. Okay, so you can find that by using select at isolation. Okay, now it is 3. So do the begin tran. Okay, and select star from test where id is equal to 20. Okay, so here I am selecting one row from test table having id is 20, right? Now let us go to another session and do begin tran, update test, set name is equal to Kumar where id is equal to 20. Will it work? It's not working. So here you are saying how the read is blocking the write operation because of isolation, right? So now let us go and see the logging here, sp_log, and you will see the similar thing what we saw before, row blocking, right? But there is one additional thing which is range. So that comes, this is part of the like isolation. So it is holding range locking. Okay, so there are two ways you can do this isolation. One is either at the query level or at the session level, right? So I showed you how to do it at the session level. Now let me show you how to do it at the query level, right? So let me roll back this one now. Okay, so the moment you will do, you will get the record here updated. Now roll it back. Okay, now let us do the same thing, I mean what we did before. So the isolation remains same because we have not done any change. Okay, begin tran and select star from test whole log where id is equal to 20. Okay, so you will get the similar thing what we did before. So you will still have the logging. Okay, update test, set name is equal to Kumar where id is equal to 20, and this will be blocked. So whatever we did before, exactly same thing but using different algorithm. Or you can say algorithm is same but the what you call command is different. So that was one at the session level and other one at the query level, right? Let us roll it back now. Okay, so the moment, okay, I should have showed you the sp log, but that will actually remain same. There will be no difference because underlying thing is not changing, right? We are holding the log, and then we are selecting and then updating. So it will not change in terms of locking. There won't be any change in terms of locking. Okay, so roll back. Now what I mean, see, this id 20 was only getting blocked. I mean, if I do update 21, that will still work. Why? Because the lock scheme is row level. So when you are updating or selecting that only for that particular row, so it will be blocking only that row, not the other row. So how about if you want to lock the complete table, okay, without really modifying anything. Okay, so let me show you how to do that. So we still have the isolation 0, isolation 3. Okay, now begin tran. Okay, now select star from test. There is no like where clause, so this will be locking the full table. Okay, so isolation is still 3, so I am holding the log. Okay, holding the log, and now let me show you the sp underscore log. What is the output of that? Okay, so here you will see like 33 shared table. There is nothing right now which is appearing. Now let us go and do the begin tran. Okay, update test set name is equal to Kumar, where id is equal to 1. It is blocked, right? It is blocked because we are holding the complete table, because there is no where clause in that. Now if you go and see this sp underscore log, you will see block, shared table block, the complete table is blocked, right? Now you can still run the select statement, there is no problem in that. Okay, that also let me show you. So select db underscore name, where are we right now? We are in user db. So we can still run select star from test, and this will still work, there is no problem. So this actually will or can help you in blocking the table for write operation. However, you can do read operation without any problem, without any issues. Okay, so we covered all that we had promised to cover. So please go through, in case of any question or doubt, do let me know and I can help you by answering those. Okay, so thank you very much, I really appreciate your time. Yeah, thank you.